Okay, so hello guys. So I figured out it would be beneficial for us to look into a more detailed example on using box plots. So here on the screen I have the example data, 9 numbers. Nothing special about those numbers, just made up, just out of the thin air. So first thing we want to do is to find the quartiles, all 3 of them. So quartile 1, quartile 2 and quartile 3. And easiest one is of course quartile 2, which is in fact just the median. We have 9 numbers here, so the median would be the one in the middle, 10 in our case. So let us put it down here. And next I want to find the quartile 1, and that just means that I want to find the median of the first half, so the median of these 4 numbers, and I see that it's something between 6 and 6, so halfway between 6 and 6, and that's of course just 6. And the same for quartile 3, so I want to find the median of these 4, and again it should be something halfway between 16 and 16, and because both of them are 16, so the halfway between them is also 16. So we have our quartiles. Alright, and now I'll go forth and find the interquartile range, and in our case it's just, okay, so it's 16 minus 6 and it's 10. Now I can find the boundaries. So 10 plus 1.5 times 10, or 10 plus 25, and it will be just 35. And I can do the same with a minus, so 10 minus 1.5 times 10, which is minus 15. Yeah, let me clean up a bit. Okay, so now if we look at those two boundaries, minus 15 and 35, you can see that our minimum, which is 5, and our maximum, which is 17, are inside those boundaries. So that means that we have no outliers, and we can just go forth and make our box plot. So in fact what we get now is called 5-number summary. Whenever you have no outliers, the 5-number summary is the way to go. So the 5 numbers are 3 quartiles and minimum and maximum values. Okay, so let's build a box plot, shall we? I'm not sure if... oh, nah. There should be a way to scroll this, I believe. Aha, yeah, so there it is. So, let me start with our midpoint, our median, or quartile 2, if you want. So let this be 10. So if I put the axis here, this is 10. Now I see that my first quartile is 6, So 1, 2, 3, 4 to the left. And my third quartile is 16. So 3, 6 to the left, to the right. And we have our box. So we have our box. It's not perfect, mainly because I do it by hand, but it's there. Next thing to do is the whiskers, and there we have two possible cases. So if some of your values are outside those boundaries, so if you have outliers, then your whiskers should start and end at those two boundaries. But in our case, all of our numbers are inside those boundaries. So in our case, our whiskers will not be reaching out to the boundaries, but rather to the minimum and maximum values. So our minimum here is 5, and it's here, and our maximum is 17, which is of course here. Okay, and if we wanted, we can add one more thing to our box plot. So let's find the mean of our numbers, shall we? If you look at the numbers themselves, so their sum is 99. You can check that. So 5, 11, 17, 25, 35, 50, 66. Am I making a mistake? No, 66, 82, 99. Okay, and we have 9 numbers. So 99 over 9 is just 11, and our mean value is 11. And that's not required, that's not necessary, but if you want, you can add that to the box plot too. So usually the mean value is marked by an X on the box plot. So now this small graph, this small picture, gives us all the info we need about our data. We see what's the minimum, what's the maximum, where the median is, and where are the quartiles, and what's the mean, and so on. And also you can notice that right half of our distribution of our data covers the larger distance than the left half. So here you have a range of 7, and here it's only 5. However, half of your data is in this area and half of your data is here. So you have the same amount of data points or data entries in each half. But that should mean that the data in this half is more cluttered together and the data here is more spread out. So your data, your distribution is not symmetric, it's skewed. So if I was going to build something like a histogram, I would most probably get not something like this neat shape, but rather something like this. Well, the asymmetry will not be so clearly pronounced because the difference is not very high here. 5 and 7 are pretty close to each other, but it will still be asymmetric. And you can also notice that from the difference between the median and mean. They are not the same, and the median is smaller than the mean, and that tells you that you have the peak to the left and the tail to the right. Well, that's all in fact. So just for the sake of clarity, what should happen if our last number was not 17? Let me go back to our numbers. Where are they? Yeah, they are here. So what if it was something like 40? So 40 is more than 35. So the 40 will be outside the boundary. So what you will do is you will stretch this whisker all the way to 35, which is the boundary, and then you will put the dot outside where 40 should be. And that will tell you that 40 is an outlier, that it does not comply to the general rules of this data. So, hope that was useful. See you guys next week.